Good day and welcome back to the Johnson Space Center as our pre-flight briefings continue for the STS-132 ULF-4 mission coming up. This is the mission overview briefing, and with us to discuss the flight today are Mike Serafin, the STS-132 lead space shuttle flight director, Emily Nelson, the STS-132 ULF-4 lead space station flight director, and astronaut Jerry Ross, the chief of the Vehicle Integration Test Office here at the Johnson Space Center, one of 2 men to fly a record 7 times in space, and the only astronaut who has flown 5 times on the space shuttle Atlantis, soon to be retired. And we'll start off with Mike.
Well, good morning, and thank you for your interest in the STS-132 mission and the planned last flight of the space shuttle Atlantis and its journey to the International Space Station. This morning, along with my colleague Emily Nelson, we'll introduce you to some key players that are going to play some pivotal roles in the mission of STS-132, along with provide an overview of the mission plan and the timeline that we have in place. So with that, I'd like you to introduce you to the crew of the Space Shuttle Atlantis. If we could pull up the photo of the crew of Atlantis. You see here our Commander Ken Ham. He will be the first-time commander on this flight, and he will be supporting the suit-up of the spacewalkers before they go out the hatch each day, as well as performing a lot of our transfer activities to resupply the International Space Station. Pilot on this mission is Tony Antonelli. You see him in the back row in the center. This will be his second flight as well, and he will be supporting the task IV role on this mission, so he'll be overseeing the spacewalks from inside Atlantis and just ensure that those happen in a timely and safe fashion. He will also be performing some of the robotic activities on this flight, along with undocking and fly around to the International Space Station at the end of the mission. Our 3 spacewalkers, Garrett Reisman, Mike Good, and Steve Bowen, will each be going out the hatch 2 times during our 3 planned EVAs. Have all flown once before. Garrett, in particular, is a long-duration flyer on board the International Space Station, stayed on board during the Expedition 16-17 timeframe. And then Piers has flown twice before in space. Piers will be our systems expert on the Russian module flying up on this flight, the Rassvet, or the Miniature Research Module number 1. And will also be supporting the robotics from the International Space Station on the station arm. All of these are veteran flyers, only 6 astronauts on this flight. We've been flying 7 in the past, and that provides with a little bit of a timeline challenge and workload challenge on this flight, but it also provides the benefit of having additional launch mass to resupply the International Space Station. I'll also provide you with an overview or some information on the crew patch. If we could show the STS-132 crew patch. This depicts the Space Shuttle Atlantis flying off into the sunset. If the 12-day mission plans plays out as planned, the Space Shuttle will orbit the Earth 186 times during its final flight. You can see it here flying off into the sunset. We orbit the Earth 16 times a day, and we see 16 sunrises and sunsets per orbit. So as Atlantis flies off into the sunset, we deliver, in this case, the Rassvet module, which means sunrise, for a continuation of the International Space Station. The mission itself is a very challenging mission. We have robotics on 9 of the 12 days of this mission. Flight day 1, we break out the shuttle's robotic arm and check it out and make sure that it's ready to go. Flight day 2, we inspect the heat shield on Atlantis. Flight day 3, we pull the integrated cargo carrier out of the payload bay and install it on station. Flight day 4, we support one of the spacewalks. Flight day 5, we install the Miniature Research Module number 1. Flight day 6 is support of our second spacewalk. Flight day 8, again, support of our third spacewalk. Flight day 9, we install the cargo carrier back into the shuttle's payload bay for return. And then flight day 10, we inspect the heat shield one last time. So 3/4 of our mission is taken up with robotics activities and provides a great combination of man and machine as we utilize not only the robotics on this flight, but our human space flyers during this 12-day mission. With that, I would like to introduce you to the key players on the ground here in Mission Control that will be supporting the Space Shuttle side of the mission. I will be supporting as the Orbit 1 and lead flight director for the mission. I'll be supporting during the first half of the crew's day, from the time they wake up through their midday meal. I'll be overseeing the rendezvous and docking operation, as well as all the inspection activities, flight day 2, as well as late inspection. Later on in the mission, during the dock portion, I'll work with my colleague Emily Nelson to get the crew out the hatch for all of the spacewalks. Overseeing the ascent operation, the launch operations on this mission will be Richard Jones, our ascent flight director. Richard is a veteran shuttle flight director. Many of you may recognize him as the lead of STS-131 that we just landed a couple of weeks ago. He will oversee the launch operations in conjunction with our colleagues out at the Kennedy Space Center and convert Atlantis from a launch vehicle to an orbiting spacecraft. This will be Richard's third ascent. Chris Edelin is our Orbit 2 flight director. Chris will be supporting the second half of the crew's day. We call it Orbit 2, from their midday meal until the start of the sleep phase. And this is Chris's second mission as a shuttle flight director. Ginger Carrick will be supporting her second mission, and she will be supporting the overnight shift and replan operations. And then Tony Sakachi is our entry flight director. Tony is a veteran shuttle flight director. Many of you may recognize him from his lead role during the last Hubble servicing mission, and this will be his first entry as an entry flight director. So now that we've overviewed some of the key players on the flight, I'd like to show you the payloads and the layout of the payload bay of Atlantis. If we could roll our first video, we'll show you the payload bay and all of the items that we plan to launch on board Atlantis. Along the starboard side of the payload bay, we have the orbiter boom sensor system that we'll use to inspect the heat shield on Atlantis. And on the port side, opposite the orbiter boom sensor system, we have the shuttle's robotic arm that we'll grapple the boom with to perform the heat shield inspection. In the front of the payload bay, we have the orbiter docking system that will serve as our mating interface to the International Space Station and provide a pressurized path to allow astronauts to go from inside Atlantis to the space station. In the center of the payload bay is the integrated cargo carrier that will provide critical spares to the International Space Station. And then in the back of the payload bay, we have the miniature research module number 1, a pressurized module that will be installed on the Russian segment later on in the mission. Emily will provide additional details later on in the briefing regarding the MRM-1 as well as the integrated cargo carrier. On flight day 1, I'll jump into the mission timeline now. On flight day 1, we'll check the weather and the vehicle systems out at the Kennedy Space Center with our colleagues and Richard Jones. Once we see good conditions and a good vehicle, we'll launch Atlantis. After launch, we'll convert Atlantis from a orbiting spacecraft, or from a launch vehicle to an orbiting spacecraft by opening the payload bay doors, deactivate all of the launch systems, and then activate a lot of the orbital systems. We'll again break out the shuttle's robotic arm, check it out, make sure it's ready to go for the inspection activities on the second day of the mission. And the crew will set up the laptop network on board Atlantis so that we can gather all of the launch data, launch imagery, and download that to the ground. Our second day of the mission will consist primarily of the heat shield inspection. If we could roll our second video, we'll show you the inspection of the heat shield. The day will start off by the crew pulling the shuttle's robotic arm out of its what we call pre-cradle position, which is an overnight stow position. They'll reach over across the payload bay to grapple onto the orbiter boom and then maneuver it into position to perform a pan and tilt survey using the camera on the end of the boom to inspect the aft end of Atlantis to ensure that there were no thermal blankets damaged during the launch phase and that there's no residual ice on the umbilical area where we flow cryogenic fluids into Atlantis. After that pan and tilt survey is complete, the crew will maneuver the arm over the starboard wing and perform a series of racetrack scans up and down the starboard wing. And then once they're done with that, go over to the nose cap and then port wing and basically do a mirror image survey of what they did on the starboard side. All told, the inspection activities take 6 hours. It's about 2 hours for the starboard wing, about 2 hours for the nose cap, and 2 hours for the port wing. The activities will be conducted by pilot Tony Antonelli and mission specialist Garrett Reisman and Piers sellers. All of the imagery gathered during the inspection will allow us to clear the vehicle from the launch phase and ensure that Atlantis is ready to come home following ascent. The imagery will be reviewed by a ground analysis team here in Houston. The engineers and imagery analysts will use all of the sensor data gathered, and over the course of roughly a day and a half, we'll review that in combination with the rendezvous pitch maneuver data gathered on flight day 3 to clear Atlantis. We expect a decision from the debris assessment team and those engineers late on flight day 3, and they'll either identify additional areas of interest that we need to go off and gather further imagery on to support a focus inspection on flight day 5, or they'll clear the vehicle. With that, you can see here the nose cap is complete, and the port wing survey is nearly complete. When the crew finishes surveying all of the areas of the reinforced carbon-carbon that see the hottest temperatures during the reentry phase, as well as survey the port side of the OMS pod in the aft end of the vehicle, they'll put the orbiter boom away to support docking operations, get it out of the way of the path of the docking mechanism for the final approach to the International Space Station, and then they'll put the shuttle's arm into a stowage position as well. At the tail end of flight day 2, the crew will also check out a number of systems associated with the rendezvous and docking. They'll install the centerline camera that is used to provide line of sight and verify the corridor alignment for the final approach and docking. They'll extend the docking ring and make sure that it is in a good configuration and ready to support the docking, as well as check out a number of the rendezvous tools that will be used to pilot Atlantis to the International Space Station. On the middeck, Steve Bowen and Garrett Reisman and Mike Good will check out the suits that will be used later on in the mission to support the 3 planned spacewalks. On flight day 3, our rendezvous and docking will culminate midday with the docking to the International Space Station. If we could roll our third video, I'll show you the final approach to the International Space Station. In the morning, the crew will wake up roughly 40 nautical miles from station, perform a series of rendezvous burns to close in at a range of roughly 600 feet directly below the International Space Station. Commander Ken Ham will stabilize Atlantis as the astronauts and cosmonauts on board the International Space Station take digital still images out the windows of the Russian segment of the heat shield on Atlantis using both a 400 millimeter and an 800 millimeter lens. You can see depicted here by the boxes emanating from the space station. All of the images will be loaded onto laptops for downlink to the ground here in Houston, again for review by the imagery analyst and engineers to help clear the vehicle and ensure that we have no additional areas of interest that we need to go review via further inspection. Following the rendezvous pitch maneuver, Commander Ken Ham will stabilize Atlantis directly below the International Space Station and then perform a quarter lap fly around to maneuver Atlantis and align it with the docking system on board the International Space Station. From there, he'll approach the International Space Station down a very narrow 2.5 degree corridor that will allow it to have good alignment for the final contact conditions. Once he verifies final alignment at 30 feet, we'll press in and perform the docking to the International Space Station. After a series of leak checks, the hatches will be opened, the crew will greet each other, perform a safety briefing, transfer a couple of critical items, including the suits used to perform the spacewalk on the next day of the mission, and the docked mission will begin. And with that, I'd like to turn the briefing over to Emily Nelson.
Thanks, Mike. Good morning. Thanks for being here. The STS-132 ULF-4 mission is a flight with a real international flavor to it. This will be the first time in about 15 years we've launched a Russian module in the shuttle payload bay. That last time was on STS-74 back in 1995 to the Mir space station. This is the first time we've taken one of our Russian modules to ISS in the shuttle payload bay. And we've been working hard with our Russian colleagues over the last year to get both the module and our teams in both Moscow and Houston ready for this flight. We're also flying the enhanced ORU temporary platform, which is a Canadian piece of hardware, along with several science experiments from the JAXA, Japanese Space Agency. So several of our partners have significant participation in this flight. In terms of U.S. hardware, our biggest objectives are to install a backup Ku-band communication system and to replace 6 of the very large batteries out on the P6 truss that are a part of the primary power system. Those batteries have been on orbit since November of 2000, and we're going to take this opportunity to do some preventive maintenance to ensure that our primary power system is good to go for years to come. Before I get into a summary of the docked mission timeline, I'd like to introduce our teams both on the ground and on orbit. I'll be, as lead space station flight director, I'll be working the Orbit 2 shift, and that'll be centered on the crew day, largely centered on the spacewalks themselves. For Orbit 1, we have Holly Ridings, and one of our more experienced space station flight directors. This will be her 4th mission, joint mission. She's also been an expedition lead flight director. Her team will be working in the crew morning time frame, and they'll be working to get the crew started on their activities each day, and then on EVA days, getting the crew suited up and out the door. Then on Orbit 3, the sleep shift, we have Scott Stover. This is his first flight as a space station flight director. He and his team will be wrapping up the crew's activities each day and then working to incorporate any changes that we've encountered over the course of the day into new plans for the next day and the rest of the mission. Then on call in the event that we run into technical challenges will be Royce Renfrew, and he'll be leading our Team 4 support. And finally, supporting from Moscow, specifically for MRM-1 installation, will be Courtney McMillan, international partner liaison, to help us out if we run into any trouble with MRM-1. And for the ISS crew on orbit today, we have a photo from left to right. We have flight engineer Mikhail Kornienko, flight engineer Tracy Caldwell-Dyson, flight engineer Alexander Skvortsov, the ISS commander Oleg Kotov, flight engineer TJ Creamer, and flight engineer Suichi Noguchi. The ISS crew are going to play several key roles during this mission. With only 6 shuttle crew members, we are using the ISS crew maybe more than we have in the past. Tracy has trained to be a critical part of several of our robotic activities throughout the flight. TJ and Tracy will both be helping Ken get the crew ready for EVA activities on several of our EVA days. And then Oleg will be working with Garrett and Piers on the MRM-1 installation day. Let's see. In addition, ISS has been a very busy spaceport this spring, possibly as busy as we've ever seen it, with not only Atlantis arriving soon, but a number of other vehicles arriving and departing in the weeks before and after the flight. This past Saturday on May 1st, we had the arrival and successful docking of Progress 37 to the Piers docking module. In this graphic, you can see where 37 ended up. Then 1 week from today, on May 10th, we'll have Progress 36 departure from the aft port of the Zvezda module at the very back of the ISS. I think we have a graphic of that one as well. And then 2 days after that, we'll have, on March 12th, Soyuz 21, which is currently docked to the nadir or Earth-facing port of the Zarya module. It'll be relocated to the aft port of the Zvezda module, which was just vacated by Progress 36. This relocation is critical to the launch of Atlantis because it frees up the nadir port on Zarya for us to install MRM-1 there. So we need to have a port for that installation before we can get off the ground. Then during the STS-132 mission itself, Suichi, Oleg, and TJ will begin preparation for their return trip. Soyuz 21 will undock from the ISS about 9 days after Atlantis is scheduled for departure, and they'll land in Kazakhstan on June 1st at approximately 10:25 Central Time. Let's see if we can review our payloads in the payload bay in a little bit more detail. We have a video of our MRM-1 module called Rassvet, or Dawn. The MRM-1 was built by the Energia Corporation at their facility on the outskirts of Moscow and delivered to KSC on December 17th of last year. In addition to the science facilities inside the module, there are a number of important items on the external of the module. You have the European robotic arm spare elbow, and the grapple fixture that'll be used by the SSRMS to position the module for installation. Then on top of the module in the graphic, you have a radiator and an airlock, both of which will ultimately be installed on the Russian multi-purpose laboratory module, which is scheduled for launch in early 2012. On top of the airlock, you can see the second grapple fixture. This one will be used by the shuttle robotic arm to pull the module out of the payload bay. And then we have a portable work platform that will ultimately be used by EVA crew members to control the European robotic arm from outside the space station. We can go directly into a video we have of MRM-1 while it was being processed at Cape Canaveral. Here you see MRM-1 outfitted and almost ready for transfer to the launch pad. Then we have the airlock again. This one, like the airlock on the Japanese module, is sized for scientific payloads and hardware, not for personnel. And then back behind the airlock, you can see the radiator that's destined for MLM, as well as there below the airlock, the portable work platform. MRM-1, as Mike mentioned, will be installed on flight day 5. It'll be attached to the nadir port of the Zarya module. That's the Earth-facing port. Here you see the docking system that'll be so critical to our installation activities as it was installed by the Energia personnel there at the Cape. This is the same docking system that is used on all of our Progress and Soyuz vehicles, so we have a great deal of experience both in Mir and ISS with this hardware. Here you see the opposite end of the module, and the docking port that will be used for future Soyuz and Progress flights. And then as the module spins, you can see the spare elbow joint for the European arm is shrouded there on the lower part of the module. And then you see the grapple fixture that'll be used by the station arm coming into view there on the right. That grapple fixture is critical to installation because it's the path for power and data to and from the module. And this is the first time we're going to install a module on ISS using the robotic arm to pass data and control to the active side of the docking mechanism. Usually for modules installed by the arm, the active half of the mechanism is on ISS, so that'll be a new operation for us. The module's about 23 feet long, weighs a little over 17,000 pounds, and here finally you see it inserted in the payload canister, ready for transport to the launch pad, where it is today, and it'll be inserted into the shuttle payload bay here shortly. Then we have another video with an overview of the ICC VLD. In the payload bay, just in front of MRM-1, the Integrated Cargo Carrier Vertical Light Deployable, or ICC VLD for short. We'll start with the space-to-ground antenna boom, which will be installed on the Z1 truss near an existing space-to-ground antenna system. Then the space-to-ground antenna itself, which we call the dish for obvious reasons. It'll be installed on the boom and will become our backup Ku-band communication system. Then we have the enhanced ORU temporary platform will be installed on Dexter, the special purpose dexterous manipulator, and it'll be used as a pallet to house the spares that Dexter will install for us. Then we have a couple of grapple fixtures for moving the pallet around. And finally, we have the 6 batteries that we'll be installing out on the P6 truss, and we'll be taking the old batteries from the truss and reinstalling them on this carrier where they'll return home in the payload bay at the end of the mission. So moving back into the mission chronology, Mike left off with the docking of Atlantis to ISS. As soon as we've had a chance for everyone to say hello, gotten the safety briefings, the crew will get immediately back to work. They will, Garrett and Steve will be gathering items that they'll need to prepare the airlock for the EVA the next day, while Tracy and Piers extract the ICC VLD from the payload bay, and we have some video of that operation. Piers will grapple the ICC VLD in the payload bay with the station arm, pull it out of the bay, and then maneuver it up to a spot close to the Z1 truss where Garrett and Steve will be doing much of their work on EVA-1 next morning. It's of note that this is the first use of the cupola module, which was installed by the STS-130 crew back in January. We, in the last couple of weeks, have relocated one of our robotic workstations into the cupola so that it can now be used as a base for our robotic operation when we finish with these activities at the end of the day. Though this animation doesn't appear particularly fast, this is quite a bit faster than what we'll see in real life. So to carry on with that operation, Piers is going to thread the ICC VLD to a spot in almost the center of the truss, where we'll then grapple it with the mobile base system on what we call the POA. That mobile base can then move from the center of the truss, where we need it on EVA-1, near the Z1 truss, out to the far port end of the space station for EVAs 2 and 3 for those battery R&Rs. On flight day 3, we'll finish up by isolating Garrett and Steve in the airlock as they prepare for EVA 1 the next day. Moving on to flight day 4, it's our first EVA day. Lisa Shore will be giving you a detailed EVA briefing immediately after, or shortly after this briefing, so I won't cover those in detail. We'll just cover them at a very high level. For EVA 1, our EV crew members are Garrett Reisman and Steve Bowen. Garrett will be EV 1 and Steve will be EV 2. Ken, Mike, and TJ will be helping them get suited up in the airlock. Tony, as Mike mentioned, will be our IV crew member helping them through their timelines through the EVAs. Piers and Tracy will be providing SSRMS support, and the SSRMS and EVA operations for each of the 3 EVAs are highly integrated, and we're highly dependent on that integrated timeline going well. The big picture items for this EVA are going to be the installation of the redundant space-to-ground antenna system and the EOTP. Then we will send Steve over to the ICC VLD, where he will release the launch torques that were put on the ICC VLD batteries, which will save us some time in EVAs 2 and 3. We estimate the EVA is going to take about 6 hours and 30 minutes. And then at the very end of the day, as the EV crew members are coming back inside, Ken and Tony will be positioning the shuttle arm immediately over the MRM-1 so that we can pull it out of the bay the next morning. The highlight of flight day 5 then will be the MRM-1 installation, and we have animation of that one as well. Not shown in the video, Ken and Tony will grapple MRM-1, then Piers is going to deactivate the module in the payload bay. It'll be pulled from the payload bay to a position where the station arm can reach it, and then Garrett and Piers will grapple and reactivate the module on ISS power. The shuttle arm will then ungrapple, move to a viewing position, while MRM-1 begins its trip across the space station over to the nadir port of the Zarya module. Again, I expect these views to be pretty spectacular. Piers, once MRM-1 docking system is aligned with the Zarya docking cone, which you'll see here shortly in the video, Piers will initiate an automated docking sequence that will complete all the mechanical, electrical, and data connections within the interface automatically. Again, this video is actually much faster than what we'll see in real life. Once MRM-1 installation is complete, we'll use the station arm to pull OBSS off the side of the shuttle payload bay, hand it off to the shuttle arm. Then, if there are any concerns about the integrity of the shuttle's thermal protection system, we'll inspect any trouble spots. And if there are no issues, then the OBSS will be positioned for viewing of EVAs 2 and 3. We'll finish up flight day 5 with a review of the EVA 2 procedures, and then we'll get Steve and Mike in the airlock to get ready for EVA 2. Overnight, the ground teams are going to translate the mobile transporter with the ICC VLD on top of it over to the port side of the vehicle in preparation for the EVA work the next day. On flight day 6, we'll start the morning off with Garrett and Piers taking the ICC VLD off of that mobile base system and getting it positioned for the EVA crew members to have access to it. Meanwhile, Steve Bowen, who will be our EV1 for EVA 2, and Mike Good, our EV2 for EVA 2, will be getting ready in the airlock. This time, Tracy and Ken will be helping them get suited up. Tony will again be our IVA, walking them through the procedures, and Garrett and Piers will provide the SSRMS support throughout the EVA. The big picture for this EVA, we're going to do 3 battery R&Rs. The goal at the end of the day, after about 6 hours and 30 minutes, is to have taken 3 batteries from the pallet, put them on the truss, taken 3 batteries from the truss, and put them back on the pallet. Then we move into flight day 7, where we get some crew off-duty time at last. We'll be getting tools configured for our EVA 3, and our Russian colleagues will be doing the very first steps to get MRM-1 opened up and begin filtering the air in that module. We won't do a significant ingress of that module until after the docked mission is complete, because it's so full of cargo, you just can't get very far into it without having some space for that cargo, and we just don't have that space when we've got 6 visitors on board station. At the end of the day, we'll be doing an EVA 3 procedure review, and then we'll get Mike and Garrett into the airlock for camp out in preparation for flight day 8, EVA 3. This time, Michael Good will be our EV1, Garrett Reisman will be EV2. Again, Tony is IV with Steve and Ken helping them get suited up in the morning. Piers and Tracy will provide the SSRMS support. We'll resume our P6 battery R&R activities, replacing the old batteries on P6 with the new ones on the pallet. Again, swapping those 3 out so that we should have 6 old batteries on the pallet and 6 new batteries on the truss by the end of this 6-hour and 15-minute EVA. We'll do some P6 cleanup at the very end, and then if time allows, there is a grapple fixture attached to the port side of the shuttle payload bay that we would like to have on ISS. So we, as time allows, we'll send the crew down there to retrieve it, bring it inside. It'll then get some minor modifications and then be taken back outside on an ISS stage EVA for installation on the FGB. At the very end of the day, we'll have Piers and Tracy maneuver the ICC back onto the mobile base system so that overnight the ground teams can translate it back to the center of Space Station and preparation for it to be returned to the payload bay on flight day 9. And speaking of, I think we have video of that activity. Garrett and Piers this time will grapple the ICC VLD with the SSRMS, and then we'll ungrapple it on the POA there on the mobile base system. Then swing it around and return it to the payload bay. And at this point, the only hardware left on that pallet should be our 6 old batteries returning home. The rest of this day is crew off duty, and we have several science experiments scheduled for execution on this day, as well as a great deal of our transfer. We don't get as much transfer done as we'd like while the guys are outside, so we're going to make up some time on flight day 9. With that, I'd like to hand it back over to Mike to brief the undocking and the remainder of Atlantis' final flight.
Thanks, Emily. Flight day 10 will wrap up the joint mission activities between Atlantis and the International Space Station crew. The crew will check out a number of the systems required for undocking and fly around, the rendezvous tools. They'll have a press briefing, a joint press briefing with the International Space Station crew, say their final goodbyes, perform the hatch closure, and some leak checks to make sure that the docking interface is ready to go for the next space shuttle arrival. And then we'll perform the undocking and fly around. We have a animation of the undocking that we'll show you. Pilot Tony Antonelli will back Atlantis away from the International Space Station at a range of 400 to 600 feet, and then complete a 1 revolution fly around, again, to obtain imagery of the exterior of the International Space Station. They'll take digital still images. Those will be downloaded to the ground for review and analysis before performing a final separation burn. The lap around the International Space Station will take about 45 minutes, and will be conducted during the daylight portion of the orbit. Following the fly around, that'll wrap up flight day 10 for the crew of Atlantis. On flight day 11, they'll start the process of returning home. As part of that, they'll perform the late inspection and give a review of the heat shield of Atlantis one more time. We have an animation of the late inspection process. This inspection is a little bit different than what we saw on flight day 2. We don't survey the tail end of Atlantis because we're not worried about ice from the ascent loading of the cryogenic fluids or the ascent environment effects on the thermal blankets. What we're looking for here is orbital debris or any damage on the hottest surfaces of Atlantis on the reinforced carbon-carbon along the leading edge. If we do notice any damage, the team will review that imagery and determine whether or not it exceeds the threshold that requires a repair. If we need to repair, we've got the tools and techniques in place to make that happen. The imagery team on the ground will use a very similar process to what they did earlier in the mission to review all of the inspection data from the boom after the starboard nose cap and port wings are surveyed, and will provide a very quick turnaround on all of that data that gets reviewed roughly a day after the inspection activity is complete. At the tail end of the inspection, we'll put the robotics away for the final time on this mission. So this will wrap up all of that man and machine work that was conducted throughout the mission. The orbiter boom sensor system will be cradled on the starboard side of the payload bay for its return. along with the shuttle's robotic arm. This will allow us to close the payload bay doors at the tail end of the mission. On the 12th day of the mission, the crew will basically button up the cabin in Atlantis, make sure all the stowage is ready for re-entry into the gravity field back on Earth, and check out the entry systems. Entry Flight Director Tony Antonelli will bring in his entry team, and they will fire up one of the AP auxiliary power units, activate the hydraulic systems, and make sure that all the flight controls as well as the reaction control jets are ready to support re-entry the following day. After stowing a few more items and doing a briefing in preparation for deorbit, the crew will come home on flight day 13 again under the leadership of Entry Flight Director Tony Antonelli. They'll be looking at the weather at the Kennedy Space Center in Florida as well as the Edwards Air Force Base in California, and we'll decide whether it's appropriate to come home on flight day 13 or if we should extend due to weather. If all goes as planned and we launch on the 14th and we fly a 12-day mission, we should come home on May the 26th in the morning at the Kennedy Space Center at around 7:36 Central Time. And with that, the mission of Atlantis and its final flight will be complete. And with that, I would like to turn the floor over to Jerry Ross, our most experienced flyer on board Atlantis.
Thank you, Mike. I've been asked to talk to you briefly this morning about Atlantis. Obviously, it is my favorite space shuttle. As was already noted, 5 of my 7 flights into orbit were aboard Atlantis. That includes my first 3 flights as well as my most recent one, which was doing assembly on the International Space Station. Atlantis really is a great flying bird, and that mostly goes to the credit of the outstanding team of engineers and technicians we have at the Kennedy Space Center that prepare Atlantis as well as our sister vehicles for flight into space. First of all, this morning I'd like to share a summary of some interesting facts about Atlantis and its illustrious history. After that, I'll be narrating a brief video summary of my flights on Atlantis, as well as a couple other noteworthy flights. That video has been prepared for me by the folks here at Public Affairs. Atlantis is NASA's 4th space-rated space shuttle. It was named for a 2-masted ship that served as the primary research vessel for the Woods Hole Oceanographic Institute in Massachusetts. It served in that capacity from 1930 to 1966. It might be interesting to know that when we flew on my first space shuttle flight, the second shuttle flight aboard Atlantis in 1985, we actually flew a piece of the plank, the decking plank, from the Atlantis vessel. And after the flight, we returned it back to Woods Hole. The construction of Atlantis began on March 30th, 1980, just over 30 years ago now. And it was completed in about half the man hours it was required to assemble the first space-rated spacecraft, the Columbia. It weighed 151,000 pounds and rolled out of its assembly facilities there at Palmdale, California in 1985. And that made it about 3.5 tons lighter than what Columbia had been. It was transported via 747 piggyback to the Cape. It completed its flight readiness firing on September 5th of 1985 and was launched on its first flight in October 3rd, 1985. Some of the more significant flights that it completed, obviously its maiden flight, STS-51J. On STS-30, we launched the first interplanetary probe from a space shuttle. That was Magellan. STS-34, we sent Galileo off to explore Jupiter. STS-37, one of my flights, was the deploy of the Compton Gamma Ray Observatory. On STS-71, the first docking to a Mir space station was completed. It was also the first time that we exchanged U.S./Russian crews. STS-76 was the first time that we performed a U.S. spacewalk on the exterior of Mir. It was also the first time that we used the new Mission Control Center for an entry. STS-106 was the first time that the crew had entered into the service module and then did the final preparations of it in advance of the first long duration stay of a crew on board the ISS. STS-98 was the launching of the Destiny Laboratory to the ISS, and that flight also included the 100th EVA performed by the U.S. in our space flight history. STS-98 was the launching of the Destiny Laboratory to ISS. STS-104 was the addition of the Quest airlock to the station. STS-110, my most recent flight, was the addition of S0 to the truss network on the station. STS-122 was the launch of the Columbus Laboratory for ESA and its attachment to the station. STS-125 was the last flight to service the Hubble Space Telescope. And STS-129 was the last time we used the shuttle to exchange crew on the ISS. Some numbers for you. To date, 31 flights. That includes a total of 282 days on orbit, during which the Atlantis traveled about 116 million miles during 4,462 orbits of the Earth. 185 crew members have participated in those 31 flights, and they included 7 dockings to Mir and 10 dockings to the International Space Station. Now, next comes a snippet of videos that has been prepared by the folks here of Atlantis' maiden flight, its first flight to dock to the space station Mir, and then a quick summary of my 5 flights on Atlantis. STS-51J, Atlantis' first launch, was in 1985, and this is never going to be routine, and it's something I'm really going to miss seeing. 4.5 million pounds of hardware, nearly 7 million pounds of thrust coming off the pad. A pretty rocky ride during first stage. My first flight was 61B. We launched 3 communication satellites and performed 2 spacewalks to investigate space station construction techniques. Ease and access were the 2 experiments we conducted. And we thought we did such a good job on this that we would go into business. We decided to call ourselves the ACE Construction Company. And it's also during this time frame that I was quoted as saying, "Let's go build a space station." STS-27 was my next flight on Atlantis. It was a classified flight, and all we could show you is us having some fun with an NFL football that we flew on board. That football was subsequent to the flight returned to Pete Rozelle, the commissioner of football, at that year's Super Bowl. On STS-37, we deployed the Compton Ray Observatory and Gamma Ray Observatory, and we had to go out and manually deploy the KU band antenna that you see here, thus saving that satellite from being about a $550 million piece of big space junk. Jay Apt and I, after we'd completed that, looked inside the windows there on the aft flight deck and saw the guys inside eating our food. After we'd completed our checkout of the Gamma Ray, we deployed it, and we were supposed to be inside the airlock, except I think the only thing that was inside the airlock at that point was our toes, because we wanted to have a great view as the satellite was released and deployed. We did a planned spacewalk on this flight also to look at a prototype space station piece of hardware called SETA, and thus the little railroad placard that you saw there. Here we are demonstrating one of the 3 configurations of the SETA cart during that flight. A couple views here of STS-71, the first docking mission of a shuttle to the Mir station. I think you can kind of tell how close the shuttle components got to the Mir station. And one of the reasons that on STS-74, my next flight, we added a Russian-made docking compartment to the Mir station. And that was then used by all subsequent shuttle flights to dock to the Mir station. It's very similar in design and structure and purpose to the hardware that we're flying here on STS-132 that's called MRM-1. A view as we're docking to the Mir station using the docking compartment. And another view as we leave the docking compartment mated to the Mir station. You can see that they also use that to mount quite a bit of hardware on the exterior A view of us in the aft flight deck windows, looking back to mirror as we depart, all smiling to the crew. I don't know what this picture is supposed to tell you. This is STS-110. This is when we installed the 43-foot long S0 segment to the station. This is the center part of the station to which all the other components have been attached. A great view as we're going across the Nile Delta and the Red Sea. And this is the last close-up view I had of the ISS as we departed and did our fly around. A very beautiful touchdown of STS-110 at the end of the mission at the Kennedy Space Center. That's always a great feeling to have a nice, pretty rollout, get back there to see your family and friends.
Okay, great, thanks. Appreciate that. We'll take questions from reporters here in Houston, then go around the horn to KSC and NASA headquarters, and we'll start off in the back. Mark Carreau.
Thank you, Mark Carreau, representing Aviation Week. And my question is for Mike. This is scheduled to be the last mission of Atlantis, and I just wonder how you'll handle the orbiter and its condition for return. Would your going in philosophy and flight rules say you don't cut any corners, or do you have some margin if you needed to let some system go on the orbiter before you landed? And I guess I'm not really asking the question exactly how I mean it, but I think my thought is there. I mean, do you want to bring this ship back as though it were going to fly again someday, or do you have some leeway in how you would handle the spacecraft?
That's a fair question, Mark. The flight of Atlantis on STS-132 is no different than any other mission that we're setting up for, whether it's prior to this or after this. We still have the same engineering constraints and the same physics apply to how the vehicle flies and to how the actual rendezvous docking and all the critical activities are going to be performed during the mission. So we still need to conduct the mission in the same manner. There is a little bit of reverence that the mission will be conducted with, given that it's the final planned flight of Atlantis. But in terms of how the overall mission is conducted, it will be identical to previous flights.
And I had a question regarding the batteries that come back from the space station. Can these be refurbished and potentially reflown, or is that a question that hasn't been dealt with yet?
As I understand it, we're working on some next generation batteries, so it's more likely that if we were to fly additional batteries, we'd fly the next generation, new technology style. And then one of the other challenges is that these are really big and really heavy, so once we're not flying the shuttle anymore, it'll be much more difficult to get them to orbit.
Bill Harwood, CBS for Emily. On the MRM-1 and the clearance issue for Node 1 Nadir, is there physical interference, or is this thing just giving you a bit of breathing space for dockings? I was unclear as to how tight the tolerances were.
You mean in terms of being able to dock Russian vehicles?
The MRM-1 was to add additional clearance for the Node 1 Nadir. I'm just trying to understand, if you didn't have it, or can you physically do this, or is it just something to make everybody more comfortable?
Well, because we have a vehicle docked there now, we're clearly able to dock vehicles to the FGB Nadir port today. It will give us some more capability and a little more leeway by having lowered that docking interface so that there's less likelihood. We don't have to protect for as many different contingencies if it's not as close to the structure nadir of Node 1.
Thanks. And one more from me on the KU band system. Mike was telling us in the previous briefing that this is a cold backup until 2011, when I guess there's some avionics going up. Can you explain what that's all about? I don't know anything about that.
Sure. So today we do have a KU band system on orbit. It's used for the larger files and the larger amounts of data that needs to go back and forth between the ground and the station. So we use it for payloads because they have quite a bit of data that goes back and forth. It's used for video. It's used for all of our timelines and our procedures that we give back and forth to the crew. We are adding, when we add this system, we can't just automatically with software today, after it's installed, just jump right over to this new system if the system we have on board today were to fail. We have not yet installed some cabling internal to the modules. Once that cabling is installed, which will be in the weeks following the mission, the crew will still have to disconnect and reconnect some cables inside the module in order to disconnect the current KU system and connect the one that we're about to install. But until we fly, the only way to get another string of KU is to go outside and get the dish that 127 installed on one of our spares pallets last summer. So this is a huge step forward for us in terms of all we have to do is tell the crew to go move some jumpers around, and then we have our second KU system available. Did that answer your question?
Mark?
Mark Hartman, Interspace News. This question's for Jerry, and I'm afraid you probably won't have an answer, but I'm going to ask it anyways. I realize shuttles don't fly that often, but in the airplane world, flyers generally equate quirks to every tail number. You know, every airplane has its little nuances, and I was wondering if in the astronaut office and among the crews, whether that's the case for Atlantis, if you have anything you can tell me about it that's different than the other orbiters that comes to mind.
Actually, Atlantis has felt different on different flights, which is unlike most airplanes that you fly in. I think if you flew airplanes with different types of payloads or loads on the outside under the wings or in the belly of a Bombay or something like that, you'd have different dynamics of the airplane. Most of the differences that I think we've all sensed between the various different orbiters or the various different flights have to do primarily with what's in the payload bay of the orbiter, because each of those has its own unique set of characteristics and frequencies, natural frequencies, and we will actually feel a little bit of a vibration going uphill depending upon what the configuration is out in the payload bay.
Hi, Robert Perlman with CollectSpace.com. First with a question for Emily. How different is the mating of the MRM to the station as compared to, in regards to ARM operations, as compared to a CBM docking both from the station crew's perspective and the shuttle crew, and comparing it to a Progress and Soyuz automated or even manually controlled approach? And do you have to do that docking while Moscow Mission Control is within direct communication with the station?
Let's see, to start, it's very different from the way that we would normally install a module with the CBM, and also somewhat different from the way that you would dock a Progress or a Soyuz. The CBM operations are executed with the active portion of the CBM. The parts that are moving are the side that are on ISS. So if you run into trouble, you can always go and change out those parts if you had to, and get fresh parts installed or scavenge them from another location. Gives you a little bit more leeway if you run into problems. With MRM-1, because the docking system is exactly the same with one minor delta, we have added an extra motor to add redundancy to this docking system. It's otherwise exactly the same as Progress and Soyuz, where you're accustomed to having, and a Soyuz especially, you're accustomed to having the crew on the Soyuz side of the docking mechanism, and it's coming in as a free-flying vehicle with propulsion and thrust. So there are a couple of things that we've had to overcome. First of all is getting data, power, communication, all of that's going through the arm, but the control goes from a laptop at the Cupola robotic workstation that Piers will be running. That's connected through our Ethernet connections on board all the way back to the Russian central computer, and then comes back through the same Ethernet connections over through the arm into MRM-1. So all of that data is going through a pretty long path to get to where it's headed, which is new and different. We've spent a lot of time testing that to make sure all that's going to work out okay. Also, I don't know how many of you have really watched Progress and Soyuz dockings, but those vehicles don't come in slowly. They come in with quite a bit of force. There's a great deal of spring force in the probe head of the docking probe that has to be overcome, and so we've also worked hard to ensure that we've got the right rates on the arm, and that the arm is able to provide sufficient rates to overcome those spring forces so that we can actually get the docking probe into the docking cone for the first physical mate. And then you had another question that I'm afraid I've already forgotten.
Do you need to do that mating while Moscow's in direct connection with the station?
The ability to see Russian data via their ground stations would be helpful in a contingency case, but for a nominal case, we don't require it. So we are scheduling it to occur in the crew morning, which is when we do have regular ground sites. And that's simply because if we run into trouble, we're going to want to have access to the additional data that's available on those ground sites on the FGB side. We get all the data we need from MRM-1 through the arm, but if we need, for instance, for FGB to let go of the probe if it has gotten a hold of it, then we'd need to get a ground site in order to tell the FGB to let go of the module.
Thank you. And a question for Jerry. Do you plan to be at the launch and or landing to see Atlantis come down for its last planned flight? And do you know if your many crew members are planning to do the same? And what do you think that will mean to watch Atlantis fly that last flight, given you said that's your favorite orbiter?
Well, first of all, I will be down there in my current job as a Vehicle Integration Test Office boss. I'm there for every launch, every landing, and every practice countdown, so I spend a good share of my time at the Cape. I don't know about any of the other crew members who have flown on Atlantis. I've not heard from any of them. I have heard that there are quite a few crew members, former crew members, in fact, that are hoping to try to get down for one of these last 3 flights. And there are some discussions about possibly trying to have some type of a reunion during one of these last 3 missions as well. As far as feelings, I think we're all have very mixed feelings with respect to the termination of the program here. I'm kind of hoping that we will find a way to fly 135 and Atlantis will get one last hurrah, but it's not certain. I personally feel that it is the proper thing to do to stop the shuttle program. I think it's time. I wish we had not had the gap develop between the termination of this program and the start of the next. But all that being said, I am looking forward to seeing it fly. Like I said, it is a great flying bird, and personally I think it's the best one of the fleet.
Hi, Stephen Clark with Spaceflight Now for Emily. Do you have any contingency plans if you aren't able to get the mini research module hooked up during the dock phase, or can you bump that later? What's your plan if something goes wrong?
Yeah, we've clearly spent a lot of time talking about that. Officially, we are on the hook to return the module to ground if we're unable to get it installed. However, that hardware on the exterior of that module is very important to our Russian partners. The cargo on the inside of the module is very important to us, so we're going to do absolutely everything we can to get the thing attached to station. Every portion of the docking system is fully redundant in one way or another, either because there was redundancy built into MRM-1 or because there's redundancy by nature of the interface with FGB, the functional cargo block module that we're installing it to. So we have walked through every different scenario for if a given system fails, then how do we engage the backup system? How do we accommodate that? If we absolutely were unable to install the module, then worst case, we would return it to the payload bay and send it home.
Okay, let's go down to the Kennedy Space Center now for questions. We'll be back here, Jim.
Thank you. It's Irene Klotz with Reuters. Just a quick question for Emily first. You said the rates are pretty fast for what we normally see on U.S. hardware. What is it exactly?
I'm afraid I don't have those numbers, but we can get those for you.
Okay, thanks. And for Jerry, thank you for that trip down memory lane. It covers a lot of years. I just was wondering what you think about the prospect of people flying to the station and low Earth orbit without having NASA being the entity in charge of it all, going to this commercial model.
My own personal opinions here. First of all, I don't think we're doing things right if we don't open up more routine and flexible ways for anybody who wants to fly in space to go there. That being said, I think that the U.S. government has an obligation to its flyers to provide a safe and proper way for them to fly into space, and that we ought to be in control of the requirements. We have to be in control of how those vehicles are certified. And we ought to have our own people that are helping us to get trained on those vehicles and to help us operate those from the ground. If we can meet those constraints, then I'm happy to fly whatever vehicle, as long as it meets all of our requirements, our certifications, it's under our control. and our crews are properly trained and happy to go fly them.
This is Marcia Dunn of the Associated Press with a few more Atlantis questions, please. Mike Serafin, you mentioned that you're going to be looking at this mission with reverence, treating it with reverence. Could you expand a little? And is there anything out of the ordinary that your flight team will be planning because this is the last planned flight?
Yeah, the last planned flight of Atlantis is going to be treated with a bit of reverence. To use a sports analogy, would liken it to the final season of a champion athlete. You know, when a champion athlete announces their retirement, folks show up in large numbers to show their respect for that particular athlete. Stadiums around the country will be sold out wherever they're appearing. And we're seeing that right now with the space shuttle program. We're seeing a lot of interest from the public showing up for not only the launches, but also the other events, the rollout from the VAB to the launch pad, the landings. And it's just an increase and an upswell in public interest and public support. That doesn't take away from the fact that we need to retire the space shuttle or the space shuttle program. We are in the 9th inning, and as Jerry had mentioned, there is a possibility that we'll have a launch on need flight or an STS-135. Atlantis may go into extra innings. We don't know. We'll see how all that plays out. As far as the ground team is concerned, you know, right now, I'm sure that we'll have a few events along the way. I don't have any in mind at this very instant in time, but I've got a little more time to think about that. I'm sure the team, being as invested in the flight of Atlantis and the space shuttle program as it is, will come up with something creative, and I will certainly welcome any ideas that they have.
Thank you. And for Jerry Ross, why is Atlantis your favorite? Other than the fact that you've flown it so many times, is there something in particular that makes it your favorite? And, you know, you are involved with all the crews going up and coming back, and I'm wondering if you could somehow summarize the rest of the astronaut corps' feelings as Atlantis gets set to make its last flight, and there are only 3 planned more flights left to the entire program.
Well, first of all, Marcia, the primary reason that Atlantis is my favorite is because of the number of times I've flown on it. Also, it was the one I flew for my first 3 times, as well as the last. And the other one was a visit to Mir, which was a fascinating opportunity as well. So it would be hard when 5 of your 7 are on one vehicle to not have that as your favorite one. Besides that, I mentioned earlier, it is a great flying vehicle. It's a testament to the talents of the people that design the hardware, but also to all the folks at the Cape who spend countless hours prepping the vehicles to go fly. And Atlantis has given us outstanding support on orbit, and I expect it to on its last planned flight. I think if you talk to the folks in the office, you get as many different opinions on what they're feeling right now as there are people, and maybe and you know, one of the common sayings we have in the office is, if you want multiple opinions, ask 2 people and you'll get probably 5 or 6. It's very mixed feelings. There is an anticipation of where we could go in the future. There is a frustration with where we are now in terms of the mixed messages we seem to continue to get from headquarters. There is, in some people's minds, a fact that we ought to continue to operate the vehicle. It seems to be the shuttles seem to be flying about as well as they've ever flown. We're flying longer missions and having less problems on orbit than we've ever had on the vehicles, basically. The couple of hiccups we had a couple years ago with low-level cutoff sensors and things like that are all behind us. The countdowns have been very smooth and very reliable recently. The only thing that we can't control, it seems like right now, is the weather. That all being said, like I said, you're going to get a lot of different opinions on what's going on. As I expressed earlier, my own private, personal opinion is that the shuttle has run its course. It's time to press on with something different.
Thank you for that answer. And you mentioned that the Russian module is going to be stuffed with cargo. I'm wondering, could you sort of summarize what cargo is going up? Is it all Russian, or is it a motley of international things? And for your flight, is this a +1 flight, or is it just straight 12 days and two 2 or 3 wave-off days?
The cargo inside of MRM-1 is all NASA cargo. We have spare parts, we're pre-positioning items for future station crews, food, clothes, those kinds of things. We have some medical supplies, a lot of what you would expect in a module that doesn't have to be unpacked right away. All of the stuff that we need more quickly, we're going to put on the shuttle middeck. And in terms of the mission duration, we are a 12+0 flight day mission. So we don't have in the bag at launch an extra day to add in, so we'll have to juggle our priorities as required if we run into any contingencies.
Okay, time for questions from NASA headquarters in Washington.
Thank you. This is Tarek Malik from Space.com and Space News, and I have a few for each of the presenters. For Mike and Emily, I'm just curious if it seems that this is a very packed mission all around. If there's I guess one chief item that really stands out as maybe the biggest hurdle you see, or is it pretty much going to be a marathon the entire time?
I can lead this one off, I guess. In terms of just the mission in general, as I mentioned earlier, the robotics on this flight is probably the single biggest key in being able to pull the mission off. We've got a lot of serial activities, both on the shuttle and the station robotics side of the house. And some of those, just due to the location of the robotics activities on the International Space Station and the amount of time available in the mission timeline, all need to happen within a fairly narrow window and in a serial manner, such that if we don't get things done, they could cascade and affect the ability to get all the content that we've got planned on this mission accomplished. Having said that, we've looked at the plan and we've got a lot of contingencies available that the team has gone off and trained and is prepared to execute. I have a high level of confidence that we'll be able to handle any problems that come our way, and whether we've planned it or not, because of the team and the system that we've got in place.
I would add that for me, MRM-1 is probably the biggest hurdle. Hopefully on Flight Day 5, it'll look like it was effortless, but if anything does go awry there, as Mike said, we have a very serial arm plan, and we need our arms to be in an entirely different place following the MRM-1 install if we're going to continue with EVAs 2 and 3. And if we're still worrying about MRM-1, then we won't be able to proceed into those activities. So once we get to the afternoon of Flight Day 5 successfully, I'll feel like we'll have accomplished our first mission objective for sure.
Thank you. And for Jerry Ross, you mentioned earlier that you thought the view of a shuttle launch is spectacular, and you're going to miss seeing it in the future. And I was just curious what your feelings were, what you can recall about the first time you actually saw Atlantis in person, maybe touched it, climbed inside it, and got that first ride. I guess what that moment was like, knowing that this could be the last flight for it.
Well, my first shuttle flight on Atlantis was the 23rd overall shuttle flight. And so I had listened to 22 crews come back and give us very excruciating details of what they saw, what they learned, what they felt on each of those missions. And I put all that information into my think tank, and every time I'd go out running or exercising or something like that, I would kind of daydream what it was going to be like to strap that puppy on and go for a ride. And I can frankly tell you that about 20 seconds after liftoff on my first flight, I was thinking to myself, Ross, what in the world are you doing here? As you remember, that was back when we still were launching in cloth flight suits and a motorcycle helmet and T-38 flight boots. We didn't have our launch and entry suits. We weren't in a pressurized environment inside that little cocoon that gives us. Those suits really do muffle out a lot of the sounds and a lot of the vibrations that the vehicle generates during first stage. And so for me, that first launch was a pretty exciting ride. There was a lot of rumbling and shaking, as I said. Since it's a lot easier to maneuver around in the seat, I was able to turn around in my seat. I was in the back right seat behind the pilot for launch. I was able to turn around and be looking back at the base of the pad and saw the water starting to come out for the sound suppression. And I thought, well, I guess I better turn around. It looks like they're going to do this. I know more that got turned around, and the engines were rumbling, and then the solids hit. And the solids hitting is kind of like somebody taking a baseball bat and swinging it pretty smartly and hitting the back of your chair. And that was the first sensation I had that, whoa, this is really pretty impressive. But literally during the first 15, 20 seconds, screeching through the atmosphere, the wind noise on the outside of the vehicle was just really incredible. It was very impressive, much more than I'd ever experienced in a jet airplane, either commercial or military. So that was pretty impressive. And when you throttle down, you don't really know that you're throttling down, but when you throttle back up, it feels like somebody just put the afterburner in. You're generating a lot of thrust, but you're adding back maybe several 100,000 pounds of thrust, but it feels like a lot more. So a lot of sensations, a lot of memories, and a sensation that Disney's e-ticket rides would never come close.
Thanks, Jerry. We're back here in Houston for follow-ups. Jim?
Yeah, Jim Olberg with NBC for Emily. A couple of questions on the MRM. This may be a program office question, but this is the slot that the Science Power Platform once had. So we made a swap about 10 years ago.
Yes, we're flying MRM-1 as part of our longstanding agreements for hardware that we're basically poundage that we need to get to orbit. And MRM-1 is actually a piece of the Science Power Platform that's been repurposed.
And in terms of the Russians as payload owners, how many Russians have really been to KSC at MAX and normal during the processing? And how many Russians will be here, and what kind of office as payload operators?
At the Cape, I only have ballpark numbers, but I know we've had on the order of 30 of their folks, of the Energia folks in particular at the Cape for processing the payload itself. Here, I am personally aware of about a half a dozen of the Russian engineers that'll be here with us. A couple of those are going to be sitting with our program integration folks. A couple of those will be sitting in our payload control center talking directly to our payloads officers. And then the rest of the team will be in Moscow, and we, of course, will have our standard loop communication with those teams. Our day-to-day operations in Space Station have prepared us well for that. It's a little bit different when the module's in the payload bay, and that we handle things a little bit differently, passing that communication to Mike over in the shuttle flight control room. But once we get the payload on the arm, then it's just as if it were any other piece of Russian hardware, and I talk to SRP and we talk through whatever we need to.
Eric.
Eric Berger with the Houston Chronicle. Jerry, thank you for coming out and talking to us this morning. It's been interesting. You were asked earlier a little bit about the differences between each of the shuttles, and I just want to clarify, when you're in the cabin, can you really tell the difference between Discovery and Atlantis, Endeavour, the other vehicles, or I mean, is everything the same and in the same place?
Yeah, all the vehicles on the inside look pretty much the same. There are minor differences, and as we were going through different modifications to the vehicles, you could tell a difference if that one modification had or had not been completed. But you know, we have just two trainers, a motion-based and a fixed-based simulator that we train all the crews in. And so they basically look the same no matter which one you're in. There are minor nuances, but not that many.
Okay, any other follow-ups? Seeing none, we'll call it a briefing. A couple of programming notes. We'll be coming up with a recap of all the video B-roll that will be fed out on NASA television that you've seen during this briefing and the prior briefing. That'll all be coming up momentarily on NASA TV. The next briefing is at 11:30 a.m. Central Time. Lead Spacewalk Officer Lisa Shore will be here to give a comprehensive rundown on all three spacewalks scheduled for STS-132. And at 1 p.m. Central Time, Atlantis' 6 astronauts will be here for their final pre-launch news conference, so you'll want to be here for that. With that, we'll wrap it up. Thanks very much.